Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Roger Berlin. Today, we're going to talk about HashiCorp Nomad. Nomad is an easy-to-use and flexible workload orchestrator that enables organizations to automate the deployment of any application on any infrastructure at any scale across multiple clouds. Roger is going to show how multiple teams can safely share a single Nomad cluster. I also want to note that this Hangout is recorded and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be about 20 minutes and then we'll allow up to 30 minutes for questions afterward. As Roger's presenting, if you have questions, please go ahead and just submit them through the GoToWebinar portal and then we'll answer them all at the end. So with that, let's go ahead and get started. Take it away, Roger.
Okay, thank you so much, Amanda, and thank you everybody for attending. I'm actually wearing my black HashiCorp t-shirt with all the logos, thinking that that would be a good idea, and then I realized once we got started that it's not visible. You can't see any of my logos. So anyways, I gave it, a good there. So I thought that's kind of amusing. So again, my name is Roger Berlin. I'm a senior solutions engineer with HashiCorp. I've been here about a year and a half, working with all of our products, and Amanda already described to you the actual topic of this presentation and demo. And we're just going to spend, I'm going to spend a few minutes showing a few slides to set the stage, but most of this will be focused on the demo itself. So the agenda is going to be a brief overview of Nomad. I'll talk about some of the key Nomad features that allow teams to share clusters and work together without stepping on each other's toes. And I'll be giving a demo that illustrates that. Amanda already essentially said what Nomad is. It's an easy to use and flexible workload orchestrator that enables organizations to automate the deployment of any applications, on any infrastructure at any scale. It's a multi-cloud solution. So customers are using this across all the major clouds, and even, running multiple clusters that are federated across clouds. Nomad helps you increase density and reduce costs. On the left side, we see a typical scenario in which there's a lot of VMs, each of which are running a single application because different teams create their own, deploy their own infrastructure effectively, and they end up allocating a VM, and it's just for that one application, and often the utilization is quite low, under 20%, maybe under 10%. Nomad, as a job scheduler, as a workload orchestrator, can actually schedule multiple applications onto the same VMs or physical servers. And get, in other words, here on the right side, we see a lot more or many more applications running on the same hardware compared to the left side, and that reduces costs. Other reasons that companies use Nomad includes ease of use. It's easy for developers to run their applications and for operators to manage the Nomad clusters. Workload flexibility is also important. Nomad supports both Docker applications, but also legacy apps. In other words, non-containerized applications, and it does that on Linux and Windows. So you're not constrained in terms of the kind of applications that you can deploy. Scalability is also important. I mentioned already that we can federate clusters across multiple regions and even multiple clouds. And then synergy with other HashiCorp solutions, primarily integration with Vault for secrets management and integration with Consul for service discovery and configuration. So those are native integrations. And customers who are already using Vault and/or Consul often find it very easy to add Nomad into their infrastructure. This is the typical Nomad workflow. You have multiple teams, who are submitting jobs. We call them jobs, but often it's just deploying an application. But they're submitting jobs to Nomad, and those jobs indicate things like, preferences as to where they want things to go, whether it should be Linux or Windows. Other characteristics of the Nomad clients onto which these jobs should be deployed. So we have Nomad servers in the middle. Nomad clients are actually where, those are VMs also. But all of these are VMs. The Nomad clients are where the workloads actually get scheduled to. So in this picture, what we see is, a team submits they submit jobs, and depending upon how busy the various Nomad clients are, the applications, the jobs get provisioned or deployed to particular clients. Now, the four features I want to talk about that I'm going to show during the demo are the Nomad Access Control List System, or ACLs. This is important in that ACLs restrict who's allowed to do various things. This is a token-based system, and the tokens are associated with ACL policies, which grant capabilities to those tokens. And of course, tokens are then allocated to people, or applications even if you're doing automation. And ultimately, it's the ACL system that guarantees that only people who are permitted to are able to run different jobs. And we'll see that as we talk about the next few features. Nomad namespaces is what allows you to have multi-tenancy in a Nomad environment, whether that be a single cluster or multiple clusters, so that teams can share these clusters without conflict. One aspect of this is that jobs in different namespaces can have the same name. Normally within a single namespace or in a single cluster that in the past that wasn't using namespaces, you cannot have two jobs of the same name, but as long as they're in different namespaces, that's okay. So the dev and QA teams can both run the same job, maybe with slight variations on it, and it's the same, the job name is the same, but they're running their own versions of that job in their own namespaces. Now, ACL policies restrict which users can run jobs in the namespaces, and namespaces are automatically replicated across federated clusters. Okay. Then we move on to resource quotas. Resource quotas is another important feature that helps ensure that different teams are not stepping on each other, because having namespaces is great, but if one team with a namespace is allowed to run as many or use as many resources as they want, then they could exhaust the resources of the cluster. So resource quotas limit the resources that each namespace can use, and that prevents teams from adversely affecting other teams and users. And of course, ACL policy restrict who can change resource quotas, right? It wouldn't make much sense if anybody who wanted to could just change their own resource quota. That would do an end run around the system. And these are also, they can be defined for a particular region, or by the way, I should say that a region, when we talk about a region in Nomad, we really mean it's one-to-one mapping of regions and clusters. So I'll say region, I'll say cluster, but they're the same thing. So resource quotas can be defined for a particular region/cluster or applied globally. And then finally, the last feature I want to talk about before we get into the demo are Nomad Sentinel policies. Sentinel is a general solution from HashiCorp that implements policy as code in the same way as Terraform does infrastructure as code. So it's fine-grained, logic-based policies. In Nomad, Sentinel can restrict jobs and the drivers that they use. Sentinel policies are applied to submitted and updated jobs, but it's done after the ACL system determines that a user is allowed to submit them. So we see that in the diagram below where a user presents an ACL token with an associated policy to Nomad, assuming that the ACL policy says that the user can submit the job, then the Sentinel policies are checked to see whether in fact the job should be allowed beyond that. So this is like an extra level of fine-grained decision making that's done. And these are also replicated across clusters. Okay, so with that, let me give an overview of the demo so you understand the scenario. I have one Nomad server deployed with 3 Nomad clients in AWS. We have 2 teams, the dev team and the QA team. Each team has its own namespace and resource quota. Alice is a developer on the dev team, and she has an ACL token. Bob's an engineer on the QA team, and he has an ACL token. And we also happen to have a Bootstrap token, which allows administrators to run jobs in the default namespace and see all the jobs in the Nomad UI. I have 3 Sentinel policies deployed that restrict jobs, and we'll see those during the demo. And we're going to see what happens when the administrator, Alice and Bob, try to run different jobs in different namespaces. And by the way, I should mention that I provisioned everything with Terraform. And in fact, that's where I'm going to go to next. Let me just minimize this video. All right, how can I get? All right, I'll just drag this down to the corner. There we go. So first of all, I want to mention too, we'll see later, this demo is available in a GitHub repository. This is something you guys can do on your own. I should mention it does actually, well, I'll talk more about that later. This is where I provisioned the demo with Terraform. This is actually Terraform Enterprise, but I could have used Terraform open source, and if you run this demo, you could use Terraform open source to provision everything. And you'll see here that I have a number of outputs from my Terraform run over here. These outputs tell me things like the IP addresses of the different servers. There's the Bootstrap token that I need for the administrator. I have the token for Alice, right? I have the token for Bob. And I have, a command for me to SSH over to the server, which I've done here in 2 different windows. We see up top, I have Alice's dev shell, and I have on the bottom, I have Bob's QA shell. I even figured out how to put that in the title of the shells this morning. So, and we have the Nomad UI and the console UI. I won't show you the Nomad UI, but over here, I do have the Nomad UI, and we see currently there are no jobs running in this cluster. We see the 3 clients, and we have the 1 server, and we can also see that over here in AWS, right? We can see I have the 1 server that's currently selected, and I have my 3 clients. Okay, so with that, let's start the demo. The first thing I want to do, so I provisioned everything with Terraform. I also here in this top shell, temporarily, I've exported the Bootstrap token so that I can do some commands as the administrator. So even though I called it Alice's shell, I'm going to borrow it. I'm going to be the administrator and borrow it for a minute. Okay, so the first thing we should do is let's take a look at some Nomad namespaces. Nomad has auto completion, which I've enabled, so I can just hit tab when I type enough of a word that it will be unique. And I can do list, and we can see that there are in fact 3 namespaces here: default, dev, and QA. And I can then go ahead, for instance, and get information about one of these. I could say, or type in status of the dev namespace. We see that it's associated with the dev quota, as I mentioned earlier, and we see the current quota limits. Nothing's being used. We could do the same thing for the QA namespace, right? So we see the exact same quota has been applied. Now, what I can also do is I can start to look at the quotas themselves. I could do, Nomad quota, and let's do inspect dev. This gives me back some JSON, but we can see up here I have different limits up in this part. The same limits we saw already, and I see current utilization, right? So we have a number of commands that let us view these quotas and namespaces. Now we're gonna see those in action a little bit later, but I want to show you the Nomad Sentinel policies. So let's do Nomad Sentinel list. We actually have 3 policies in place, as I mentioned. The first of these is called allow Docker or Java driver. And it's a hard mandatory policy. That means nobody can override it. The second one is prevent Docker and host network. That one is designed to prevent Docker containers that are scheduled by Nomad from using the Docker host network or the host network of the VM or instance that they run on. That's a soft mandatory policy. So that means users with appropriate permissions can override the policy. And then we have this restrict Docker images policy, which limits us to certain images. Let me show these to you, or at least a little bit of them. We can do Nomad Sentinel, and I can do or type read. I can't remember the command sometimes. Let's do the first one. I'll copy and paste. Oh, you know what? I better do this up top. Sorry, because Bob may not have permission to see these things. So let's do Nomad Sentinel read, and we'll take this first one. Now, I should explain what drivers are. Drivers is a Nomad concept. We have different drivers for different kinds of jobs. So we have a Docker driver to deploy any Docker image, and we have a Java driver to deploy any Java application from Java, WAR files, jar files, etc. And we have other drivers as well. So what this rule essentially is saying is that the driver has to be one of these 2 drivers, Docker or Java. Specifically, what we'll see in a little bit is we're not allowing the exec driver. The exec driver allows you to basically launch any shell script or any kind of Linux level, Linux or Windows, command. In other words, you're going to fork out to the operating system and either run a script or a program, a binary, or a command. And so we're not allowing the exec driver here. Let's go back to our list of the Sentinel policies and let's look at the next one. We can do Nomad read, and let's go back here and maybe we'll just look at one more. We can look at let's look at the restrict Docker images. I think looking at 2 is probably enough. This one has a little more stuff up at the top where we have a list of allowed images, Nginx and Mongo. And I'm not making any claims here or making any statement, about Nginx being better than any other web server. I'm just showing how we could restrict things if we wanted to. Task config image has to, we're using something matches. I'm saying that it has to match something in that allowed list, plus it has to have a tag at the end. Docker containers generally are referred to, with an image name, colon, plus a tag. But I'm actually saying this is a regex expression. I'm saying the tag has to start with a number because I don't want people to use the latest tag, right? Because that can cause problems. And then every Sentinel policy, by the way, has a main rule. So we have this notion of Sentinel rules, and then every rule has a main rule. And in this case, the main rule for all these policies just says that the other rule has to be true. Okay, so with that's the Sentinel policies. Let's take a look at some of the jobs that we have available here. So when I deploy this, I deploy each of these Nomad files is a job. So we, for instance, could look at the sleep Nomad job, and we see that this is a pretty simple job. It has a task called sleep. It has a driver, but it's using the exec driver, which is not allowed. And the command it's going to try to do in that is the sleep command with an argument of 60 seconds. All right, well, let's try to run it anyways, even though we know it's not supposed to be allowed. We can do Nomad job run, and we'll do sleep Nomad. And here we get this violation. So Sentinel is stopping this allow Docker or Java driver policy is preventing this job from being run. So we see Sentinel in action here. Now the next thing we can do is let's look at another, and I'm still the administrator here. Let's look at the catalog Nomad job. This one runs a number of things. This has a group called catalog. Tasks, by the way, Nomad runs jobs include groups, which include tasks. So I have a catalog task, and I have a catalog group with a catalog task. This also uses Docker, and that's using an image that would not be allowed. But it also has network mode equals host, which is not allowed. So if I try to run that one, if I come up here and I run the catalog job, we're also going to get an error from Sentinel. Now, Sentinel actually didn't report both problems here. It just reported the first policy it happened to come across because that's enough to say, hey, it failed. This happens to be just the way Nomad does things. Like in Terraform, Sentinel would report all the policies that failed, but Nomad is keeping the output a little shorter. However, in this case, I want to show you how we can override a policy. So let's go back, do the same command, but I'm going to add in, let me add a little bit of space. This will help. Now I can do policy, sorry, that's not working. Let me do Control C on that. Nomad job run. Yeah, there we go. I think because I had something after it, the auto-completion didn't work. There we go. So policy override catalog Nomad. Now, by the way, I want to go to the Nomad UI, and if we go to the jobs, now we see that, first of all, over here in this shell, we see that I had two warnings, and the text is all printed yellow, but we see preventer host, Docker host network. That policy was violated, but we're allowing it because we overrode it. We also see restrict Docker images was violated, but again, we're allowing it because we have the policy override. And here we can see in the Nomad UI that job is now running. And it's running actually, if I refresh the screen there, we see that it's actually running in the default namespace. But I also have my dev namespace and I have my QA namespaces, none of which right now have any jobs. All right, so we're going to move on. What I want to do next is I want to start to talk about the resource quotas. And so what I'm going to do is in this shell, let me do a clear there. I'm going to actually export Alice's token. So now I'm going to, in that top window, I'm going to be Alice, who's a developer. So let's export Nomad token equals that token. And now what we can do is what we can do first of all is we can look at the tokens itself. So I can say token, Nomad ACL token self. We can look at her token. Her token is a type client, meaning it's limited. It's not a management token. It's associated with the dev policy. So we can see that. We could also do Nomad ACL policy info dev to see more about that. We can actually see the policy. This is the ACL policy. So we see that this policy has write permission on the dev namespace, but it doesn't have anything for the QA namespace. Nomad is a deny all by default. So initially, unless you grant a token policies, it won't have any permissions at all. this policy can do a few other things, but for our purposes, what we care about is the namespace. So with that, let's do this. Let's look at, there's a web server test Nomad job here. If we look at that, note that the namespace for this one is QA. So Alice should not be able to run that. But let's have her try it anyways. She'll do Nomad job run web server test. And sure enough, she gets an error. Now, this is not a Sentinel error. This is different from the other ones. This is a 403 permission denied error. That's coming just from the ACL system itself. Now let's switch to Bob's window, right? Because Bob's on the QA team. He should be able to run this. So let's actually go in here and try that. He also gets a warning, but it's a different warning. He's allowed to run it, but there's this error. We're violating the Sentinel policy, restrict Docker images. Let's edit that file and see why that's happening. If we do that and we search for HTTPD, we see that the image here is the Apache web server, HTTPD. Let's replace that. Bob, being a good citizen, wants to, he could override the policy, but he'd rather, respect the company's policies that he works for. He's going to put in a valid tag here. So Nginx, and then the tag is 1.15.6. And now let's make sure we're over here if we're actually on the, let's go to the QA namespace so we can see that happening. Now we'll try the previous command. And now this thing is running. And the UI should refresh, but maybe it won't. There we go. It didn't refresh automatically. But here we see that the web server test job is now running in the QA namespace, right? So, and we have 2 tasks, etc. Okay, so that's good. Let's move on. And so far, we haven't really dealt with resource quotas, right? We've dealt with ACLs and Sentinel policies, and we've seen that different people can run jobs. Sometimes you can't run jobs at all because of the Sentinel policies. Those are global in scope. Let's take a look at, let's go back to Alice's shell. I'm going to clear this, or try to clear it. Oh, I get caps locks. There we go. And let's do this. Let's look at, remember, there are other jobs here. Let's take a look at the website Deb Job. Now, if we look at this, it has 2 groups. It has an Nginx group with a count of 2. That means it wants to run 2 instances of Nginx. And down here, we can see that it wants 500 megahertz of CPU for each instance and 512 megabytes of RAM for each instance. Now, it also has a MongoDB group, and the development team is trying to run the same amount of resources, right? So it's going to be a total of 2,000 megahertz and over 2,000 megabytes of RAM, of memory. Okay, so let's have Alice run that job. So job run website dev nomad. She's allowed to run that. It's going along, and we can go look at the dev namespace, and we see that that job is now running. It's still being deployed. 2 of them are running, 2 of them are still being started, but that's all good. Now let's come back to Bob's shell. And oh, I see when I do clear, I lose my label. Oh well. And if we come back to job space, let's remind ourselves that Nomad has the quota in place for him, right? It has we can do the status of QA. Currently, remember, he ran that 1 job already, right? If we go to the QA namespace, remember, we have web server test running, which is using basically a 1 gigabyte of memory. Now, if we were to look at the website QA Nomad file, this is almost identical to the one that we just ran for Alice. However, the QA team is trying to use more memory. The QA team wants to use 1,024 megabytes for each of the 4 instances. Well, what's going to happen there is that's going to be too much. They're going to exceed the overall quota. But let's do it anyways. Let's see what happens when Bob does this. So we'll have Bob type nomad job run website QA. And sure enough, we get this error here, failed to place 1 allocation, memory exhausted, 5,120 would be needed overall for this job plus the job that was already running, and that's greater than the 4,100 limit. Let's refresh this, and here we see the website job. Now here's an important point I want to make, and we're actually almost done with the demo here, but an important point I want to make is Nomad didn't reject the job altogether. What it actually did, the task, of the 4 tasks that Bob tried to run, 1 of them is currently queued, right? So it says 1 unplaced, but it's queued. We have 3 running and 1 queued. What that means is that Bob or another member of the QA team can go look at what other jobs are running and maybe kill one of those jobs, right? So if Bob comes back and looks at the jobs, he sees that, oh yeah, that web server test job that I ran earlier, I really hadn't meant to leave that running. I forgot about that. He can go ahead here, stop this job, and then he can come back to the website job. And now what we see is that's actually queued and starting, and now that's been started. So we now have 4 tasks running there, 3 of which are healthy, but the 4th one, that'll turn to healthy in a second, and then it'll change. There we go. So this shows resource quotas, right? So the good thing here is that basically everybody involved is happy. The development team, the dev team is happy that the QA team wasn't able to use more resources on the quota than they were allocated, because that, otherwise that could have interfered with what the development team was doing. The QA team's happy because they have the flexibility to start at their own jobs and stop them if necessary and be able to run what they need to do. And the security team is very happy because the security team has been able to implement policies that restricted what drivers were allowed, what Docker images were allowed. Obviously they could have done many other kinds of policies as well, but those Sentinel policies help ensure that, that there won't be any security breaches or problems caused through the company's use of Nomad. So bottom line here is that we were able to see that multiple teams were able to share a single Nomad cluster. And with that, I'll just go back briefly to the PowerPoint presentation, and I want to mention, before I take questions, that I do have a GitHub repository, the one I briefly showed you. And so that, does let you, the fact that the Nomad, this is part of the Nomad Guides repository, which has a lot of good content and information about Nomad, including both Nomad Open Source and Nomad Enterprise. This multi-job demo does need Nomad Enterprise, so you would have to contact HashiCorp sales to get some AWS keys that would let you download it, but they'll be happy to provide you with that if you're interested, and then you'd be able to run through this demo and other demos on your own. I did also recently, Amanda helped me publish a blog post to Medium that basically walks through and describes this demo in more detail. And once the video recording is ready, that will be posted both to the HashiCorp website and to this blog post. So with that, I am happy to take any questions that anybody, I know that the team has been gathering questions. So maybe Amanda, do you want to, or somebody, I think Ryan maybe is going to tell me what questions are being asked.
Yeah, Roger. So we have some questions, definitely. And if anyone else does have questions, please go ahead and submit them, and we'll get them in the queue. So Roger, first question, someone's just wondering, everything you showed, are all of these enterprise-only features?
They are. Well, the ACLs actually are an open source feature. So ACLs you do have with Nomad Enterprise, but the namespaces, the resource quotas, and Sentinel policies are all part of Nomad Enterprise. The way we differentiate things generally is we have open source features kind of target individuals and smaller, small teams, whereas enterprise features focus on, multiple teams working together in large organizations that need to collaborate. And sometimes also things at larger scope. So when you're talking about federation, whether it's Nomad or Console, those are the kinds of features that are enterprise features.
Yeah. Okay. Awesome. And then the next question, Roger, we get asked this a lot. It's always great to clarify on. So someone's asking, how does Nomad compare and differ from Kubernetes?
It's a very common question. There's a lot of similarities. Nomad, I would say, is architecturally simpler in that you have a single binary, and that same binary is used both for the server and for the client. You don't have to set up complicated things with, Nomad clusters. If you're doing a managed service, from one of the clouds, of course, they manage that for you. But if you're doing a Kubernetes cluster on your own, there's a lot of VMs you need to deploy for a lot of different pieces of that architecture. I think the main things that make Nomad different, other than simplicity of its architecture, are the fact that it's not limited to Docker containers. Kubernetes generally people use only for Docker. There's some version of it somewhere that I guess you could use Rocket, which we also support, but most people only use it it's pretty much limited to Docker. The other thing too is that we can very easily run jobs on both Windows and Linux. Those are some of the flexibilities that we have with Nomad.
Yeah. Okay, great. And then next question. So Someone's wondering, are there any plans to have access to Sentinel, namespaces, and quotas in Nomad open source?
I think that's pretty unlikely. I mean, I think, like I said, we have a certain philosophy about where which features end up being enterprise. The reason we have enterprise, I remember the first HashiConf I attended before I was an employee. I was actually interviewing with HashiCorp, and they invited me to attend. And I remember being impressed that Mitchell Hashimoto, one of our founders, made the statement that the reason we have these enterprise products is to help fund the open source products, right? So unfortunately, if you're from an open source point of view, I mean, I don't think it's unfortunate, but it is the nature of companies like this is that by having enterprise products that we have companies pay us for, that does help us fund, the open source features, and we're continuing to improve all the open source products through that.
Yeah, and like you said, Roger, it's also a philosophy thing, right? So, like, unlike you sometimes see at other companies, our open source isn't a lesser than product, it's just different needs. So open source will get a lot of people everything they need. Our enterprise is always those features that are for, larger orgs, more complex orgs, multiple teams. So, okay, and then next question. So let's see. So someone's wondering, Roger, so this is only one cluster. Could they have multiple clusters connected?
Multiple clusters can be federated. Maybe what I'll do is just briefly show, because I think it's useful anyways. You'll see that in the Nomad documentation. This is where we see the Nomad enterprise features. So there's one other enterprise feature called Advanced Autopilot. There's a few more that are kind of being added, but in terms of federation, one useful place to look other than the docs is the guides, where you can look at operations. You also have, I think under operations, there's multi-region federation is a topic that talks about that. So it's very easy to join multiple Nomad clusters together. And as I mentioned in the slides, the teams, the resource quotas, and the Sentinel policies are automatically replicated across the clusters. Now, that doesn't mean necessarily that they're applied. Like a resource quota, you either target a particular region/cluster or you apply it globally, but that resource quota will be available in all the clusters. So if I happen to be connected to a particular cluster and I want to inspect the resource quota, or I want to apply the resource quota to a particular namespace, I can do it no matter which cluster I'm connected to.
Okay, great. And then next question. So someone's wondering, this is a great question, how can they integrate Nomad with Vault and Console?
So that's done automatically. Oh, sorry, I shouldn't say automatically, but that's built in. Where we'll see that is it's kind of all through the job specification file. Sometimes there are some Nomad server configuration things that are done. But for instance, when I'm specifying a job, there's a Vault specification, there's a Vault portion of that. So part of that is I can indicate secrets that I want to get. And there's something similar going on for console. There's something called a template. In particular, if you're familiar with console template is built into Nomad so that you can set up and start to do things. So I actually have I have another example that I could show. I'll see if there's how much time we have, but if there's time, I could bring up another repository I have from a different demo that actually uses both the Vault integration and the console integration. I didn't use either of those in this demo though, but it's quite easy to do. There's mostly a question of adding certain things into your template stanza, and then you have some things you do at the server level. So in other words, you specify your console integration in your server configuration file, and you specify your Vault configuration, in your Nomad configuration file. So it's quite easy to do. It's all, you don't have to deploy any extra software. It's just a configuration question. The software you need to integrate is already there.
Awesome. Okay. And then next question, Roger, someone's asking if there are any plans to have job level ACLs.
Well, ACLs are applied. ACLs can be applied to a number of different things, and that includes namespaces, resource quotas, and things. I think actually, if we take a look here if we go back to the guides, we can see all the things that are currently available under the ACL system. So this is the access control guide. And through here, this is where it talks about policies and tokens, capabilities and scope. These are the different things that are currently in scope. So namespace, agent, node, operator, and quota. So there are things you can place restrictions, ACLs, in terms of who's allowed to access different agents and nodes. I don't see there anything specifically about jobs, but insofar as you assign people effectively to namespaces, you're limiting their ability to launch jobs.
Okay. And so next question, someone's asking, how do I enable, oh, this is a good one, Roger. How do I enable autocomplete on Nomad? And is it available in open source or just enterprise?
That is an open source, and that's actually, let me see if I can find, I think it's at the very beginning of the CLI documentation. I just found this the other day myself. It's right here at the top of the CLI. So when you go into the CLI, it's just this command right here. I can make this bigger. Well, that doesn't help. Nomad-autocomplete-install. Now, one note is you need to then exit your shell or you essentially, what I did is I just, at the beginning when I was setting up the demo, I typed that command in, and then I exited the SSH session that I have, and then I connected it back again, and then that was available for that shell. So do exit or resource your shell or whatever you need to do, rerun your bash profile or something, or just add that to your bash profile. But yes, that's really nice to be able to do that, right? It's hard to remember some of these things, and it's nice to be able to type SEN for Sentinel and then hit the tab key.
Okay, and we're almost to the end of the questions, Roger. I just have 2 more. So if anyone else has kind of been debating about submitting a question, go ahead and do that now so we make sure we get to it. So someone's wondering, do you have to run commands from the Nomad server or can they be remote?
Oh, they can absolutely be remote. I just happen to be doing them on the Nomad server just out of convenience. But absolutely they can be remote. In fact, something that might be worth interesting to show, just to point that out, is this is the code that I actually have for my Nomad demo, the Terraform code that I had to provision all this. And so what's interesting about this, let me make this a little bigger, is we actually have, this points out also the integration with Terraform. So we have, Terraform has this concept of providers, and there's a Nomad provider, there's a Vault provider, there's a console provider. So here, this module here is pretty much where I provision most of all of the AWS infrastructure. But then you can see here, I'm using the Nomad. Terraform resources always start with the name of the provider. So you can see I actually created the Nomad namespace remotely. I mean, this was running on the Terraform server, so obviously it was talking to Nomad remotely. So this wasn't using the CLI directly, but it was under the covers, right? So I created the Nomad dev namespace, I created the QA namespace, I created an anonymous ACL policy, all through Terraform. I created the dev ACL policy, I created the QA ACL policy, I then created the tokens, the ACL token for Alice and for Bob. I created my default resource quota. It's called quota specification in Terraform, but I created my dev quota, my QA quota, and then I did things here where here you can see actual commands. These are actual Nomad CLI commands. I did Nomad namespace apply -quota, and here I'm using a Terraform variable to refer back to the quota. I'm passing in my token, so I had extracted my Bootstrap token, and I'm specifying the address of the of the Nomad server, and I'm saying the name of the namespace that I want to do, right? So you see a number. I actually ran the Nomad CLI from Terraform remotely to attach the quotas to the namespaces. And then I have a few other things that get done. I have something at the very end that stops all the jobs. I have a script that stops all the jobs, and that's run, that is run on the server actually. Okay, next question, Amanda. Sorry.
Yeah, so that's all right. So now someone's wondering, how does Console Connect integrate with Nomad?
I happen to have a demo for that as well, as it turns out, which I created. And so that's another demo. So in the Nomad Guides repository, if we go back up, so I was looking at the demo there. If we go to application deployment, and if we look at Console Connect with Nomad, there's a demo there that I created that gives you exactly what you need, running the catalog Nomad Console Connect demo. Now we're working on improving this integration. Right now, what I did, I won't show you the code, but I had to I pre-registered the Console Connect proxies with Console, and then I used Nomad to trigger everything. Here's what I will show you is that in the shared file here, I have my job file here, and if we open that in GitHub, right, we can see that I have a catalog group. This particular demo uses one web application, a Go web application, and it uses a database, and they're both Docker. So here I have, this is where I'm running the particular, this is the actual catalog application, right? That's the web application. But down here we see the catalog proxy. So I'm actually launching the proxy with Nomad. Now I'm using a script to actually run it. So I'm launching a script, but notice that the arguments I'm passing into the script, the port and the IP of the proxy are being dynamically generated by Nomad. And that's the main benefit of using Nomad to run your console jobs with Console Connect, is that you can dynamically generate all the ports. So, and by the way, this is an example, this is a good example. Here's a console template. So we see the console integration right here where I'm actually using a template to generate a file, and then that file is what I'm using in this run script. So that shows the console integration there. And then there's a second proxy further down, there's a second group, and there's a second proxy, what's called an upstream proxy. That one I'm running just locally, so I'm actually running the console, and I'm running the connect proxy command, and I'm giving several different arguments for that, again, using dynamically generated ports and IPs and things that were generated by Nomad. So that's a good example. That this is something, again, this was in the Nomad guides under application deployment, console connect with Nomad. You'll see that demo, and that's you can do with open source.
Great, Roger. And actually, I bet for some people on the line, maybe we should back up a bit. So, we have six open source tools. 4 of those have enterprise as well. Do you want to just give like a 1-sentence explanation of what console is for those that aren't familiar?
Yeah, and maybe it's worthwhile just if we go look at sorry.
Yeah, you can pull up its page on our site.
I mean, just in general, the products. Now, these are the ones that are enterprise products, right? So we have the ones that are commercial are Terraform, Vault, Console, and Nomad. But maybe it's better if we go look over at the open source. So we could go look over at. Sorry, I'm trying to get rid of. Oh, well, here we see all 6, right? So that's perfect. So Terraform is about provisioning infrastructure. That includes provisioning to all the major clouds, and also on premise for VMware and OpenStack. So Terraform is infrastructure as code, where you're codifying how you want to provision your applications. Vault is secrets management. That's about managing your secrets and who can access them. And Vault's very interesting, and it's very much focused on helping applications. Vault can dynamically generate short-lived credentials and secrets. Things like AWS keys, and for other clouds, also database credentials, right? So short-lived, dynamically generated credentials, so that your applications aren't using credentials that are a year or 2 old. Console is service discovery, also service configuration and registration, and also service segmentation. And what we mean by segmentation is with Console Connect, that's providing the segmentation where you can have multiple applications. So the demo the thing I just mentioned about the catalog demo, there's a catalog web application and a database, and I can define something called an intention, which is basically sits between. It determines which console services are allowed to talk to each other. Nomad we just went through, so we've covered Nomad. Vagrant is kind of aimed at developers. It's something to kind of help them manage and run, source locally and be able to do things. And then Packer is about building images and various kinds of images, whether Amazon, AMIs, AMIs, or VMware images. And so Packer can be used to help you build images that you then would use with Terraform or with Nomad or other products.
Yeah. Okay, great. Thank you so much, Roger, for running through those. And as Roger showed,
I thought I'd just show the blog. This is the blog post that will walk you through this demo as well. Has some screenshots, some from the slides, and defines these things, and this kind of walks through the whole demo flow, right? So for those who, if you want to refer some of your colleagues who maybe couldn't attend this, well, they'll be able to see the recording as well.
Yeah, well, so everyone will get the recording, and in that email, I'll also include the link to Roger's blog post. So like Roger said, you can read that. It perfectly aligns with today's demo, and you can also, feel free to share it with colleagues. Okay, so then Roger, the next question, we have just 2 more, and we're just about almost out of time. So how are the TLS configurations dynamically reloaded in Nomad?
The TLS meaning, in other words, the encryption. So in other words, Nomad, between the servers, you can set up TLS to make sure that things are encrypted. I think you're asking what happens if you change your certs or something like that. I'm not 100% sure about that. We could research that and get back to you as far as like whether you need to I think the question probably is asking whether or not you have to restart the Nomad servers or clients, or whether you can change those TLS configuration online, automatically. This is where they mention the TLS, and sometimes hopefully this would indicate whether or not you need to restart or not. But I'm not sure. I suspect that you would need to restart the agents to take advantage of those, of any changes you made to your certs.
Great. Okay. And then final question. This is a great one. And Roger, you are with customers all the time. You really see what's happening out in the real world across all different sizes. So someone's wondering, typically at which point in the Nomad adventures do you typically see companies moving from Nomad open source and transitioning to the enterprise?
Well, I think that'll depend on the customer. In some cases, if a customer is a small startup or internet-based startup, they may be fine with open source forever, right? Or, well, obviously, eventually they'll grow big, right? I mean, here at HashiCorp, we're a company that when I joined a year and a half ago, we were 130 employees, and I think now we're close to 500, right? So companies do grow, but smaller companies might do just fine with the open source features, depending upon their needs. Larger companies can start with open source, certainly. And it's, by the way, it's very easy to make the change because you're basically just swapping out the binaries. So it's not like you have to go redo. Your current clusters that are running open source could very easily be upgraded to use enterprise, but you just start replacing the open source binaries with the enterprise binaries. So it's not like you're going to have to redo everything. So it's a question of as the size of the teams grow or as the number of teams grow, certainly in terms of, again, looking at the Nomad specification features down here, we covered the three main features, right, that are currently exist in Nomad Enterprise. Advanced Autopilot is another one, which is more focused about kind of from an operational point of view, automating your upgrades, and there's some enhanced read scalability, redundancy zones, right? These are operational concerns. If you're running large clusters or if you're provisioning hundreds or thousands of applications and jobs, then these are things that would be helpful. There are some new things coming out currently, like I have to remember where this is, but there's some new things coming out soon, and I have to double check. I'm not sure whether those are going to be enterprise or open source features, so we'll have to find out. But we're doing a number of things.
Kind of goes back to Roger what you were talking about earlier, right? It really depends on company size and just what your needs are and how complex they are. So some companies may go on to Nomad Enterprise from day one. They can already see, hey, we're going to need those features. Others, like Roger said, maybe they're a startup, they're just fine. If that startup grows, they're going to get to the point where they need those more enterprise type features for larger orgs. So.
And these are the two features I was thinking of, Amanda, affinity and spread. And these appear to be open source. They're not designated. I mean, this is in the Nomad 09 beta. We're currently in beta with Nomad. If I went to the download page, you would see that it shows 0.8.7 as the current version, but it does also let you download the beta, a release candidate for 09. And that does add these extra features of affinity and spread, which is a way to control where multiple tasks or jobs go. So that's some interesting new improvements that we've added. And we're doing some other things related to plugins. You can now create your own pluggable task and device driver. So there's a number of new things coming out in Nomad 09 that you might want to look at.
Great. Okay, thank you for showing that. So with that, that is all of our questions for the day. Thank you so much, Roger, for getting through all of those. And then as I mentioned to everyone earlier, this Hangout was recorded and we will make the recording available on our website after processing. I'll send an email to everyone who registered with that recording link. Also, if you liked what you heard today and you want to start exploring Nomad, maybe you haven't, really used Nomad at all yet, I encourage you to check out our Learn site. You can find it on our website at learn.hashicorp.com/nomad. I hope you all enjoyed today's Hangout and have a better understanding of Nomad's enterprise features that safely support multiple teams using a single Nomad cluster. So thanks for hanging out with us today, and a big thank you to Roger for his time today. That wraps things up for us. Have a great day, everyone. Goodbye.
Bye-bye, thanks.